for the difference of means. Okay, it's much the same as the hypothesis test for proportions and the hypothesis test for means. In this last section, the hypothesis test for difference of means, we're going to compare two means, right? One mean is well, here are the setups. If you're testing for a difference in means, as far as setting up the hypothesis test, the null hypothesis is always going to be mean 1 is equal to mean 2. If you're testing for a difference in means, and if you're actually reading through the problem, and we're going to take a look at some examples, and it says that you're testing if mean GPA for the night students are different than the mean GPA for the day students. The alternative hypothesis is that mean 1 is not equal to. So this equal to bar with the slash mean is not equal to. All right, so the first mean is not equal to the second mean, and that hypothesis test is for a difference of means. If you're testing that mean 1 is greater than mean 2. All right, here again, the null hypothesis is that the two means are equal. The alternative hypothesis is that mean 1 is greater than mean 2. So when we actually set up these tests on the calculator, our test is going to be based on the alternative hypothesis. And then for the last scenario, mean 1 is less than mean 2. Okay, so here again, the null hypothesis are that always that both means are equal. And the alternative hypothesis is mean 1 is less than mean 2. Now, in some instances, notice that here we have greater than, and for our alternative hypothesis, that inequality is greater than. For the next setup, we have less than. So notice that for our alternative hypothesis, the inequality is less than. In some instances, you're going to be, or you may be given, so here's two more scenarios. The mean will mean 1 is greater than or equal to mean 2. Let me just actually write this out. Mean 2. All right, so notice that in this hypothesis test, we tested for greater than or equal to. So when we set up our alternative hypothesis, okay, we must include the greater than or equal to inequality. All right. Okay, so as you're reading through the problems, you want to pay close attention if what you're testing is greater than or if it's greater than or equal to. Okay, because if it's greater than or equal to, you must, in your alternative hypothesis, list that out with the equal to bar. Okay, and in the last scenario, mean 1 is less than or equal to mean to. Okay. So writing this out, the null hypothesis is always that the means are equal. And in this case, the alternative hypothesis is that mean 1 is less than or equal to mean 2. All right, so notice less than or equal to is in our hypothesis test, and the inequality for the alternative hypothesis is less than or equal to. Now, when we use the calculator, we're going to use a 2-sample t-test. Okay, for all of the hypothesis tests that we're using in this last section, 4.5, we're going to use 2-sample t-tests because the population standard deviation is unknown. Okay. Also, when you're dealing with this calculator, you're going to be asked for pooled. So the way that this questions are set up, for pool, they're actually talking about the variances. And you would only use yes for pooled, and that should be pooled, if the variances are equal. Okay. And so I kind of went through this, and in the last problem, there's only 3 problems in the last section, 4.5. And the last one, it says that the variances are equal, but you still want to use pooled as no. Okay. And then your hypothesis test is based on the alternative hypothesis. Okay, so much like the hypothesis test for proportion and the hypothesis test for means, before you calculate everything, it'll ask you if it's not equal to, not equal to, greater than, or less than. Okay, so we're going to base those off of the alternative hypothesis. All right, so let's look at some problems. Oh, there's one more other thing I need to mention. Okay. For the p-value. So there's a saying that goes for the p-value, and this is whether you're dealing with the difference of means, if you're dealing with the proportion, or even just a single mean. If the p-value is low, then the null must go. Okay. So in other words, that means if you have a low p-value, then you're going to reject the null hypothesis. Now, when you're given an interpretation of the test results, you never, ever, ever, ever accept the null hypothesis. You're either going to fail to reject the null hypothesis. Okay, so failing to reject, and then you're also going to accept the alternative hypothesis. Okay, but you never accept the null. Okay, you either reject it or fail to reject it. All right, so here's the 2 setups for the p-value. If the p-value is low and or smaller than the significance level then you're going to reject the null hypothesis. Right, so the conclusion should be there is enough evidence to support your alternative hypothesis. Right. So if you reject the null hypothesis, if your p-value is low, or if your p-value is smaller than your significance level alpha, you're going to reject the null hypothesis, and the conclusion is that there is enough evidence to support the null hypothesis. Okay, let me just move this over. All right, and then this is the second interpretation you may have. Oops. So this side is for a low p-value. And over here, we're dealing with a high p-value. Right? So if you have a high p-value, you're going to fail to reject the null hypothesis. Okay. So failing to reject the null hypothesis is different from accepting the null hypothesis. You're going to fail to reject the null hypothesis, and your conclusion should be there is not sufficient evidence to support the alternative hypothesis. Okay, so notice in those conclusions, they don't mention anything about the null hypothesis, right? If you have a low p-value, then there's enough evidence to support the alternative hypothesis. And if you have a high p-value, there's not enough significant evidence to support the alternative. Okay. All right, so any questions about the p-value? Okay, and this is true for all of the hypothesis tests in Module 4. Okay. All right, so we're going to refer back to this. All right, so let's look at the first problem. And this is from 4.5, and there's only 3 problems in 4.5. Okay, but the problems in 4.5 are similar to the problems in 4.3 and in 4.4, okay, as far as interpreting the test results. All right, so this says you're testing a claim that the mean GPA of night students is different from the mean GPA of day students. So we're testing if the mean of one group is different than the mean of the other group. All right, so we're testing the difference of means. All right, so that's this first setup. Okay, that mean 1 is equal to mean 2. That should be the null hypothesis. The alternative hypothesis is that mean 1 is not equal to mean 2. All right, so it says you sample 40 night students, and I'm going to write this down because I'm going to transfer it back to OneNote. You sample 40 night students, so our sample size is 40. And a sample mean GPA of 2.21. So 2.21, that's going to be the mean for the night students. Right, so we're going to call the night students mean 1, and we're going to call the day students mean 2. Okay, and I'm going to write all this down on OneNote. Okay, so we sample 40 night students with a sample mean GPA of 2.21 and a standard deviation of 0.54. Right, so that would be the standard deviation for the first group. You sample 55 day students. Right, so that sample size for the second mean is 55. There's a sample GPA of 2.27. So that would be the mean for the second group and a standard deviation of 0.8. It says test the claim using a 1% significance level. Assume that the population is standard deviation unequal and the GPAs are normally distributed. Give answer to at least 4 decimal places. All right. So I'm not quite sure if I can put all of this stuff up on the screen at the same time, which I can. All right, so this is 4.5, number 1. So we have group 1, which is mean 1, and then we have group 2, okay, so group 1 was the day students. We have group 2, well, excuse me, group 1 was the night students, excuse me. And we have group 2, which is mu2, and that's the day students. Okay. All right. So we're going to list all of these items for group 1 and group 2. So X bar 1, that would be the mean for the night students. This SD sub 1, that's just the standard deviation for the first group. And N sub 1 would be the sample size for the first group. All right, so the mean for the first group is 2.21. The standard deviation for the first group is 0.51. The sample size for the first group is 40. The mean GPA for the day students, which was group 2, was 2.27. The standard deviation for the day students we have as 0.8. The sample size for the day students is 55. So our hypothesis test is that mu1 is equal to mu2. And the alternative hypothesis is mean 1 is not equal to mean 2. All right. All right, so is everybody okay with what we're doing so far? Okay. So now I'm going to bring up the calculator. And I'm going to just shrink this down a little bit. And just let me double check 42.2. I'm just checking what I have, and it seems like the standard deviation is 0.54. 55, 2.27, and 0.8. So the standard deviation for that first group should be 0.54. This is kind of just double checking what I have. All right, so now that we have all of the information that we need, can I kind of double check everything? I want to go into stat. I want to go over to test. And I want to go down to two-sample t-test. So we use the t-test when the population standard deviation is unknown. All right. So now we're given the statistics. So the data would actually mean we would put in some information for list 1 and list 2, and we would let the calculator calculate these things. But since we're given the statistics, I'm going to hit statistic. Right. For X bar 1, that's 2.21. The standard deviation is 0.54. The sample size is 40. The mean for group 2, which is the day students, is 2.27. Standard deviation for the second group is 0.8. And the sample size is 55. All right, so whenever you're working with two means, okay, you must know all 6 of these statistics. All right, so now for the hypothesis test, we're going to base that on the alternative hypothesis. So we're testing for a difference in mean. So not equal to mean 1, not equal to mean 2 is highlighted. So I'm simply going to hit enter, or go down. For pooled, you always want to use no. I'm going to go down to calculate, and it calculates the test statistic and the p-value. All right. So let's see, the test statistics is, and it says round to 4 decimal places, negative 0.4361. All right, so in order to round this to 4 decimal places, you would go out to the 4th decimal place, 1, 2, 3, 4. All right, which is the 1? You will look one number to the right. If that number is 5 or greater, you round up. But if it's not 5 or greater, it stays as it is. So we have 0.4361. Okay. And also we're given the p-value as 0.6638. All right, so if I go 4 decimal places, 7. I look one number to the right. That's 5 or greater, so I'm going to round that up to 8. 0.6638. Oops. All right, so mean 1, and it's hard for me to see that. So mean 1 is equal to mean 2. And for our alternative hypothesis, we have mean 1 is not equal to mean 2. We have the test statistic as negative 0.4361. The p-value is 0.6638. So next we have to determine the decision. So now if we take a look at our significance level, I believe it's 1%. Yeah, it's a 1% significance level. And if we look at our p-value, it's 0.66. All right, now here is one thing you can do. Right now, this is a percent and this is a decimal. I can actually change this to a percentage. Okay, whenever you change a decimal to a percent, you will simply just move that decimal 2 places to the right and add your percent sign. So to change a decimal to percent, move decimal 2 places to the right and add percent sign. And I'm actually going to still write it on the thing for the virtual lecture. So which one is greater? It's going to be the p-value, right? Let me just write that again for the, I'm just so used to writing on the board. So the significance level is 1%. The p-value is 0.6638. So we're going to change the p-value to a percent. So to change the decimal to percent, move the decimal 2 places to the right and add percent symbol. So we get 66.38%. So now if we compare the two, we see that the p-value is higher. So if we go back to our p-value. Right, since we have a high p-value, we're going to fail to reject the null hypothesis. And then in conclusion, there is not enough evidence to support the null hypothesis. So we're going to fail to reject the null hypothesis. And the correct summary would be that there is not enough evidence to support the claim, right? So there is not enough evidence to support the alternative hypothesis. So the claim would be actually what we're stating in the alternative hypothesis, that the two means are different. All right, that the mean GPA of the night students is different than the mean GPA of the day students. All right, any questions about that example? Okay. So once you put everything into your calculator, you will get a test statistic and a p-value. Right, I would then convert the p-value to a percent. Compare which is bigger. So if your p-value is lower, your conclusion would be over here on the left-hand side. But in this case, we had a high p-value, so we failed to reject the null hypothesis, and we stated our conclusion. All right, any questions about that problem? Okay, now the second problem instead of giving the statistics, we are given the data. Okay, so here's just the difference in the two problems. It says a researcher takes sample temperatures in Fahrenheit for 15 days from New York City, and that's from group 1. So notice for group 1, which is New York City, there should be a total of 15 temperature values. And 23 days from Los Angeles, which is group 2. So for group 2, there should be 23, and I can't make this any smaller, but there should be 23 temperature readings. Right? Tester claimed that the mean temperature in New York is different than the mean temperature in Los Angeles. So since we want to know if it's different, the null hypothesis is that the two are equal. The alternative hypothesis is that the two are not equal. Right? It says use a significance level of 0.10. Right? So that would actually be a 10% significance level if you were to convert that decimal to a percent. Then it says assume that the populations are approximately normal, normally distributed with unequal variances, and then they give you the two data sets below. So unlike the other problem where they gave us the mean, the standard deviation, and the sample size for both groups, here they're only giving us the data. So for this problem, the first thing you want to do is go into stat. You want to go into your list, so you want to hit edit. And then for list 1, you would put in all of these data points. For list 2, you're going to put in all of these data points. And it may take a while to do that, but okay, I'm going to attempt to do it. So this is 77, and it's very easy to make a mistake on this because you're putting all this stuff in by hand. Right, and then you would put in list 2. And it seems like the calculator, okay, it froze up on me. Okay. So hopefully I put all of these numbers in right. I do have bad eyes. But you put all of the data points in for list 1. There were 15. Put all of the data points in for list 2. So once you have entered the data in your calculator as a list, I'm going to go back into stat. I'm going to scroll over to test and scroll down to 2 sample t-test, right? And I'm going to hit enter. All right. So now you see, now we're going to use this data because we have the data in the list. So if I were to go over to data and highlight that, So before we had like the mean 1, standard deviation 1, and N1. Here I'm just, for list 1, we just put in list 1. Because the calculator is going to calculate the standard deviation, the mean, okay, and all those statistics. For list 2, we have in list 2. So that's similar as X bar 1, SD1, N1, and this is the same as X bar 2, SD2, and N2. Okay, we're going to leave the frequency as 1. Since we're testing for a difference in means, right, we're going to use that first option. The pool variance is always no, and we're going to hit calculate. So it calculates all that stuff for you. You just have to make sure that you put all of the data points in correctly. So notice that we're given the test statistic and the p-value. Okay, so give me 1 second. I'm going to pull this back over. So mean 1 was for New York City. Mean 2 was LA. And we're testing if mean 1 is different, so that's not equal to our significance level is 0.1. Okay. All right, so this is 4.5, number 2. So we're given New York temp, which is mean 1. We're given Los Angeles temperatures, which is mu 2. So our null hypothesis is mu 1 is equal to mu 2. So the hypothesis is that both of the temperatures are the same. The alternative hypothesis is mu 1 is not equal to mu 2. Okay. So next we're going to write out the test statistic, which is negative 3.0518. The p-value is 0.0078. So now we're going to compare the significance level and the test statistic. The significance level and the p-value. So here we have the significance level. Is 0.10. And we have the p-value is 0.0078. Now, since both of these values are in decimal form, there's really no need to convert to percentages, although you could. All right, we could move 2 decimals to the right. So our significance level is 10%. For the p-value, we have 0.78%. So which one is bigger, the significance level or the p-value? Right, well, it's going to be the significance level, right? Because 10% is bigger than 0.78%. So that means that we have a low p-value. So if we go back to our interpretations, if we have a low p-value, then we're going to reject the null hypothesis, right? And there's enough evidence to support the alternative hypothesis. So we're going to reject the null hypothesis. And we're going to say there is enough evidence to support the alternative hypothesis, right? And the alternative hypothesis is that the means are different. Right? So there is enough evidence to support the claim that there is a difference in mean temperatures. All right, so any questions about that problem? All right. All right, and in the last problem, okay, it's going to be similar to the first problem. They give you the mean, the standard deviation, and they give you the sample size. Okay, you just have to put them in as statistics, get your test statistic, compare your p-value and your level of significance, and then write out your conclusion. All right, so any questions about that last section? Okay. So these steps as far as the p-value and the conclusions, okay, this p-value is going to be similar for all 4.3, 4.4, and 4.5, whether you're doing a proportion, a mean, or a difference in means. All right, so any questions about anything up to this point? Okay, so today is the last day of class. We won't meet again on Wednesday next week. All of the assignments are due, and I'm actually going to post that in the announcements page. The final exam is due by Wednesday at midnight. There is a final exam quiz, I believe. Yeah, there's a final exam quiz. You want to make sure you take that final exam quiz because it is similar. It's not exactly the same, but it's similar to the final exam. All right, so if no further questions, class is dismissed, and have a good rest of the semester.